The use cases for Ethernet switching are seemingly endless. Certainly, the use of Ethernet for automotive applications is a significant step forward for in-vehicle communications. While Ethernet switching and benchmarking are well understood by networking professionals, those topics are almost certainly new territory for those responsible for designing and building automotive systems. How does one bridge that gap? Hi, I'm Kevin Tolley, founder of the Tolley Group. Welcome to another episode of Tolley on Technology. Today, I am joined by Thomas Schulze, who is Senior VP Sales and Marketing at Zenith Technologies. Thomas, thanks for joining us for today's podcast. So I would like you to help build a bridge between the two worlds of automotive design and Ethernet switching with our discussion today. Zenith Networks is in a very interesting position in working with both the switch silicon manufacturers and the automotive manufacturers. So Thomas, let's start at the top. Can you please define automotive Ethernet for our viewers and give us a little context with respect to traditional Ethernet switches, similarities, differences?
Sure, Kevin. So in general, the automotive industry started around 15 years before with the integration of Ethernet in the vehicles. They started easy with diagnostics and update system for the cars. But pretty much 1-2 years after they started using standard Ethernet in the car, they found out that they can use even better Ethernet as their core in-vehicle networking system, because Ethernet is so flexible and has such high bandwidth. Because when you talk about traditional technology for in-vehicle networking, we are talking about technologies like CAN, LIN, FlexRay, and these technologies are very limited on the bandwidth. So we're talking about 1 megabit, or the highest bandwidth with non-Ethernet technologies is a 150 megabit solution, which is called MOST. It's an optical system, but it's only used for infotainment. So the automotive industry thought about how can they use Ethernet also for the in-vehicle networking in general, and not only for diagnostics or updating their systems. So what they have analyzed is that in general, the technology fits perfectly into the automotive electronics world. The only concern they had was the overall usage of the copper cables, because the core difference between the traditional networking solutions within vehicles and Ethernet was that they used all the time a simple 2-wire unshielded twisted pair cable for CAN, for example. And the Ethernet, as you know, is fiber optics, or is even like an 8-pair shielded twisted pair cable. And that is something which produces for sure a lot of weight within the car. So what the car industry has done is they invented almost a new standard, which was called that time broader reach. And to be honest, it was not really invented for the automotive industry. So one big chipset manufacturer invented this technology to bring 100 megabits to homes. So it was somehow an Ethernet standard for long distance on a simple telephone wire. So that is something then the automotive industry adopted. Again, it was called broader reach. 100 megabit Ethernet standard full duplex, but on an unshielded 2-wire twisted pair cable. And that is now evolved also to higher speeds, like we have a gigabit speed on this 2-wire cable as well. But we're also talking about even higher bandwidth, like 2.5, 5, and 10 gigabit Ethernet based on the same physical layer solution. So that's really the evolving of automotive Ethernet. Everything else within automotive Ethernet is almost the same as we know from the standard Ethernet. And that makes it also so attractive for the automotive or even the whole transportation world, because then they can really use their network as a service-oriented network, right? In the past, it was really application-oriented or feature-oriented network. So that's really the core evolvement from the Ethernet standard in automotive.
So it really is Ethernet, right?
It is really Ethernet. The only real difference is the physical layer standard, which is a single pair, unshielded twisted pair. And if you look into this standard, so like a 100 base T standard is now called in the automotive industry 100 base T1. Yeah, so the one at the end makes it automotive Ethernet.
Right, so it's an additional physical layer, but the Ethernet framing, everything else is exactly standard as we would see it.
Correct.
Okay, and that's obviously has very important and very positive connotations kind of throughout the ecosystem, right? So
yes.
So let me move ahead there. So ecosystem. So that was very helpful in understanding kind of the essential thing. But to me, knowing a lot about the networking ecosystem and knowing nothing about the automotive ecosystem, can you talk a little bit about that kind of next layer up, what that automotive Ethernet switching ecosystem is and has in it, what the components are?
Sure. So in general, when we talk about the automotive industry, or if you talk with people coming from the automotive industry, they have a traditional, let's say, ecosystem, which starts with the car manufacturer, right?
Okay.
So the BMWs, the Fords of the world, and they are usually called OEMs. So a little bit different what we know from the telecommunication industry.
Right,
But
what we call
the end, the manufacturer of the car is called in the industry or in the ecosystem, the OEM. And they have different tiers of suppliers. So usually everything which is an electrical system, for example, or a whole, let's say, domain, like an infotainment domain, which is built into a car, is coming from their tier 1 suppliers. And the tier 1 suppliers are traditionally the Boschs, Continentals, Denso, Aptiv, and how they are named, right? And they are the integrator of, or they are building, let's say, the switches for the automobile manufacturers, for the OEMs. But they are also getting their components from the tier 2 suppliers. And the tier 2 suppliers, again, are the traditional chipset manufacturers, which we also know from the telecom and IT industry, right? And they are providing the PHY chips or even whole switchboards to the tier 1 suppliers. And again, they are integrating this into electronic control units or even in whole domain systems, which are delivered then to the car OEM, and they are building up these then into the full system of the car.
So is there, for example, let's say Bosch, use as an example, when they build a switch, does that switch more or less the same thing when it goes to let's say a Ford as an OEM or BMW as an OEM? Are they trying to keep it standard the same way as we would know, standard switches?
So the switch they are building, or which they are built into these electronic control units, are usually standardized. So the only difference you would have is that for sure every OEM, so a Ford would probably get a different electronic control unit as GM would get, right? But the switch technology or the overall switch functions are potentially the same. What they would add are specific features like protocols like time-sensitive networking or something like this. But the switch hardware are usually the same. But for sure, the different car manufacturers have different, let's say, specifications to validate these switches, right?
Right. So then just one other kind of little follow on here. So today in 2022, two-part question. What's running over these Ethernet networks in the cars? And let's say if you can see 3 years from now, what functions will be running over those same networks? Does that question make sense?
That makes totally sense. And I'm often asked, what are we seeing today on the streets, which potentially works already on Ethernet, right? So as I said, they started with simple things like diagnostics, or the first Ethernet system which came out in a serious car was a 360-degree camera system, right? So like BMW, who released an X5 like 10 or 12 years ago with the first 360-degree camera system, that was based on automotive Ethernet. And after that, a lot of infotainment systems were developed on Ethernet. Now we find more and more also advanced driver assistance systems, but components first, because they are not relying on Ethernet for the full system. especially when it goes to safety critical systems. They are still more, let's say, carefully to use Ethernet as a standard because of the, let's say, usual methodology how Ethernet works. But you can see more and more the camera systems are all working on Ethernet, and even the latest electric vehicles we saw from Volkswagen, for example, and that's nothing which is confidential. So even their core backbone, their core communication backbone for the car is running on Ethernet as well.
Good. All right, now moving to a topic near and dear to my heart, switch testing. Right?
Very good.
Yeah, with traditional switches, the specifications are only a starting point for buyers. And by that, I mean, one looks at port types and speeds and the general list of features such as QoS to decide which models are applicable to a given use case. Then with a short list of switches, it's time to benchmark throughput, key features like VLANs, QoS, and so forth. And then, once you're armed with that data, only then can you really decide which switch is most suitable for your application or your car. So Thomas, can you walk us through how this process takes place in the automotive ecosystem? How is it the same? How is it different? How should it be?
Sure, Kevin. So in general, the automotive approach to test these switches was completely a different approach in the past, as we know this from the standard telecommunication or IT market. And the reason why they took it different is that they are not completely wrong on this. They said, our environment where we use Ethernet is much more controlled as it would be in a big service provider. That means they exactly know how many switches or how many devices are within the car, and that's static, right? So they do not have really a dynamic environment within the car network, which is clear because you will not change specific network configurations within your car every other month or every other day, right? So what they started to do is creating own test specifications and very generalistic test specifications, which were done in own, let's say, Ethernet standard groups within the ecosystem. So one big, let's say, standard organization, which we know in the automotive Ethernet space, is the Open Alliance. That's something you can find in the web as well. So the Open Alliance really designed the initial test specification for switches, and based on traditional test methodologies for Ethernet switch testing, they built it very specialized and simple test cases for Ethernet switch testing within or for the automotive industry. But they clearly found out, and that's something which we see today as a strong process, that these limited tests or very predefined tests for a static environment is not enough. So they now, let's say, learn that it makes sense to test also more things on a switch, which they probably don't have in their test specs. So they're moving more and more to traditional benchmarking and switch testing, which we know also in the telecommunication industry under the RFC 2544 or the RFC 2889. So the traditional benchmarking tests for switches. But again, still one big difference between the telecommunication testing and the automotive switch testing is that they have to have specific, let's say, test cases designed for a specific OEM or for a specific tier one, because they have a specific need for, let's say, a delay within a network, and they only have the allowance of 3-4 hops within a network. So it is much more defined, and that makes it also more difficult to test Ethernet switches.
Okay, so traditional things that we know about, as you mentioned from the RFC 2544, throughput, latency, which are important in the data center, and this is for a service provider, also important for an automotive. What about things like QoS, VLANs, those types of features? Are they important now? Are they important in the future?
So actually they are used in the automotive industry. So they do a lot of quality of service within VLANs. Okay. But what they have, or what they are introducing right now, is a more advanced quality of service with the time-sensitive networking, right? Time-sensitive networking brings a lot of new protocols. And the good thing is all of these protocols are in layer 2. So they are switch related, and they are hardware coded within the switches. That gives reliability, and this gives also highest performance. So they are using a lot of these quality of service metrics from time-sensitive network, also redundancy functions and synchronization functions. So within a car, you can imagine it's very important that the whole network is almost like a synchronous network, right? We have known from ATM and so on. So these are additional, let's say, protocols they are using on layer 2 to make the automotive Ethernet network even more stable and more reliable.
Okay, so here's a two-part question that follows on to that. So who and when, right? So who should be testing and when should they be doing the testing? So the who, is it the tier 1 provider? Is it the OEM? Is it at time of initial purchase, or also regression testing as new features are put on, or all of the above?
So in general, and that's for us as testers, it's a good thing. Automotive is testing everywhere and every time.
Okay.
So it is something they are not doing today on Ethernet because they are still in the learning curve, but that's something you can see with all traditional technologies or even all applications they are running within the car. So it really starts with a chipset manufacturer who has to prove that the device is performing as expected. And then the integration work at the tier 1 supplier when they are designing and building the electronic control unit. And then when the OEM, the car manufacturer, assembles the whole system, right? And even they are having multiple test steps to go from R&D or from, let's say, design of the car until start of production. And then also we see Ethernet testing already starting in the production line testing, not directly within the car production, but at the tier 2 suppliers, tier 1 suppliers, for example, when they are producing the ECUs, they're also testing switches on the production line.
Okay, so is it important for the OEM to know that the switch has headroom? For example, I'm using a particular model of switch for the current year car build. I probably don't want to be switching out switches every model year, right? I mean, I'd like to have one that I can use and I'm confident in. I've built up my testing, and I know when I add new features, additional high-def cameras or whatever it might be, that the switch can still handle that. Is that right, or am I missing something?
No, that's something they're not doing really. At least the traditional car manufacturers, right? Because they have still the process that they are planning a model for 5 years, right? And that's it. So they are trying to implement everything which they are planning today to keep it up and running for the next 5 years. But all the new guys, like Tesla or all the new electric vehicle companies we are seeing in the US on the West Coast, or we are seeing in China, they are planning with headroom because they have the model like the mobile phone companies, right? So they are delivering updates every other day. So they really need to plan with headroom, also on the bandwidth, and that they are able to allow these feature updates and general updates to the car. So it depends a little bit to which car OEM you are talking. So the new, let's say, new era car manufacturers are doing this today, but also the old guys are following this with their new car lines, like Volkswagen with the ID line, for example. They are much more flexible and much planning more headroom in this.
Yeah, which is that's a key reason for testing, to see how far you can go. That's
exactly.
So last question I have, I'm going to flip it around. So testing requires commitment, right? Commitment for training, for test gear. So there's CapEx and there's OpEx for that. So it's easy to imagine someone, maybe even the more traditional OEMs, putting it on a future to-do list, right? My New Year's resolution, some point in the future. So Thomas, in your opinion and expertise, what is the exposure for those that do not test their automotive Ethernet switches at all, or enough, or sufficiently? What's the exposure for not doing it?
Yeah, I think what I have seen in the ecosystem is really that So the reason, the question is really also why they are not testing, right?
Okay.
So,
okay.
and the core thing, what I always see in discussions or when people from the automotive industry talking with me is that because they are coming from a different world, so you have to imagine within a CAN network or LIN network, the network was just the cable, right? So they still don't have this new concept completely in their mindset.
Yeah.
And now with Ethernet, every switch connected to the other switch could turn down the whole network, right? That is a complete new, let's say, experience for them.
Yeah.
So, and that is one reason why it's not so tested. And that's exactly what we see today with companies, especially from these old processes, which I mentioned,
Yeah.
that they are not testing the switches, and they find out if they connect multiple ECUs in a network, and we are talking about like up to 100 ECUs in the modern car, and potentially every ECU has an Ethernet connection, and then maybe 10% of these ECUs are Ethernet switches, right? So, and they find out if they connect these to each other, and they're coming from different suppliers, right? So because one, let's say a Ford Mustang has not only Bosch components, they will have Bosch components, Denso components, so different suppliers, and they find out interoperability is not working, or even the protocols or the Ethernet itself is implemented on a different way. So they find out, okay, the old way of testing, if I test the features of an ECU, automatically the Ethernet switch below that is working as well. So now they find out, oh, we have interoperability problems. We have problems how the Ethernet is implemented in different vendors. So now they find out, okay, we have to test like the telecommunication or like the information technology.
Yeah, well, I mean, for years and years, you know, for a decade or more after Ethernet switches were common in every data center, we were doing interoperability testing to show everything worked. And yeah, and usually everything would work or could be made to be working, right? I mean, there's very complicated protocols, there's standards, but they're implemented different ways. And the only way to be sure is to do that testing. So it seems like education is a big thing too, right? That's from what you're saying, right? On both sides, but maybe more on the OEM side.
And I've always one nice story from my experience. I talked to a big OEM, and they said, okay, we have a new central gateway for our premium series car, and it has an Ethernet switch implemented, and our test plan has 70,000 test cases. And I asked, okay, how many are related to Ethernet? Oh, 0. So they really implemented 70,000 test cases to test this gateway or this central system, and no one was related to Ethernet. And then they used it, and they found out, okay, within the combination of other switches, it was not working.
Yeah.
And then doing the fault analysis, the root cause analysis is very difficult because you have not done the basic switch testing,
Yes,
right?
that's
you
right.
don't know what is not working.
Yeah, no baseline there. Wow, good stuff. So Thomas, thanks. So Xena has a significant product offering in this area. Where can our viewers go to find out more about Xena Networks and your automotive Ethernet solution?
Yeah, it's pretty simple. We have a very good website representing our automotive offering. So if you go on xenanetworks.com, one word, you find the solution page and then the automotive solution page, and the attendees can then see all our solutions. It's pretty easy because, as I said, or as Xena usually said, we are only Ethernet focused, so they will not find tons of different test solutions. And we also have like use cases and white papers how Ethernet should be tested. So for all automotive folks which are not really experienced in Ethernet testing at all, you find everything on our xenanetworks.com webpage.
Good, so there's education there as well, which is
exactly
we've identified as being key. Great. So Thomas, thanks for your insights today. Thanks everyone for joining us, and check back soon for another episode of Totally On Technology.
Thank you, Kevin.